Today we're going to look at how zero and negative exponents work, and we're going to begin with this pattern of powers of 2. The first couple of these I can do without a problem. 2 to the third I know is 8, 2 times 2 times 2. 2 squared is 4, 2 to the first is 2. Then I come to something that's probably unfamiliar, 2 to the exponent 0. How do I do that? What does that mean? I certainly can't do it the way I did 2 squared by saying take 2 and multiply it by itself 2 times. That doesn't make sense when I talk about 2 to the 0. So what I'm going to do instead is I'm just going to notice that I have a pattern in the powers going down the left here, and I've also got a pattern of answers going down the right. And so logic would tell me that given the pattern that's happening here, the next number in the sequence of answers, these have all been divided by 2, should be 1. And in fact, if you go to your calculator and you go 2 to the exponent 0, you're going to see that in fact it comes out to be 1. Alright, so then the pattern of powers continues and we get into the realm of negative exponents, which again is probably a new idea. But again, we can take advantage of the pattern of answers on the right. The answers are dividing by 2, so the next answer should be a half. And in fact, if you go to your calculator and you enter 2 to the exponent negative 1, you're going to see that it says 0.5, which is a half. And then a half of a half would be a quarter. So that should be the next answer. And again, the calculator would confirm that. And the next answer after that is 1/8, a half of the quarter. You'll also notice that there's a pattern between answers with positive and negative exponents. So for example, 2 to the negative 3 gives the same answer as 1 over 2 to the positive 3. In other words, its answer is the reciprocal of what it was when we had a positive exponent. And so these patterns tell us how zero and negative exponents work. If you have any number to the exponent 0, it's going to come out to be 1. A to the exponent 0 is going to come out to be 1. With one exception, a can't be 0. And in terms of negative exponents, 3 to the negative 2, the answer to that will be the same as the answer with a positive exponent except over 1. So the reciprocal of the answer with a positive exponent, in this case 1/9. So a to the exponent negative n would be 1 over a to the positive n, where a can't be 0. So let's look at a number of examples of how negative and zero exponents work, because this is a new idea. It takes a little bit of getting used to. So let's take negative 3 to the exponent negative 2. And so by my definition of negative exponents, it means to reciprocate the base and make the exponent positive. Alright, and so negative 3 times negative 3 would be 1/9. What if you have a negative exponent in the denominator? Again, you can confirm this with the calculator. If you type in 1 divided by 3 to the negative 2, you're going to see that you get the same answer as 3 to the positive 2. So if the negative exponent is in the denominator, it brings it up to the numerator and becomes positive, and that becomes 9. How does a fraction with a negative exponent work? Alright, well, by our definition of negative exponents, it would be 1 divided by our base to the positive power. That would be 1 divided by 2/3, and dividing means multiply by the reciprocal, and so we would get 3 over 2. And so there's a little bit of a shortcut you can use when you're dealing with fractions to a negative exponent. You simply reciprocate the base and make the exponent positive. So if you had 4 over 9 to the negative 2, we can see from our previous example the answer should be the same as 9 over 4 to the positive 2. We then square the numerator and the denominator and we get 81 over 16. couple more examples. 2 times negative 4 to the exponent 0. Alright, so as long as our base is not 0, a non-zero base to the 0 exponent, this is 1, and so 2 times 1 would be 2. What if I had 4 divided by 3 to the negative 2? Alright, so the way I'm going to handle this one, first of all, this is not the same as this. Let me just make this a separate question. We just talked about a fraction to a negative exponent, meaning we reciprocate the base, make the exponent positive, square numerator and denominator. Here the negative 2 is only on the 3. So what I'm going to do is I'm going to take this expression and I'm going to break it up into two different fractions. I'm going to go 4 over 1 multiplied by 1 over 3 to the negative 2. This multiplied by this gives me this back again. Alright, so my answer will be 4 times, and I have a negative exponent in the denominator, and so a negative exponent reciprocates, which pushes me back up to the numerator, 3 squared, and so I have 4 times 9 is 36.